Show that d by dx of x log x minus x equals log of x. And 2, we've got this diagram here. In the diagram, C is the curve y equals log of x. The region R is bounded by C, the curve, the x-axis, and the line x equals E. Find the exact volume of the solid of revolution formed by rotating R completely about the x-axis. The region R is rotated completely about the y-axis. The region R is rotated completely about the y-axis. Explain why the volume of the solid of revolution formed is given by pi e squared minus pi, the integral between 0 and 1 of e to the 2y dy, and find this volume. Right, let's have a look at this then. Here's the actual question then in summary form. So part 1. So let's differentiate that. Here, answer is equal to, this is a product then, u times dv, so it's x times dv, which is 1 over x, plus v, which is log x, times du, which is 1, minus this differentiated, which is 1. So this is x over x, which is 1, take away 1 is 0, and we get 1 lot of log x. So that differentiates to log x. So what that means in effect is the integral of log x is this. So with that thought in mind then, let's go on to part A. Find the volume when R is rotated about OX. So we're going to draw, take cylindrical slices, circles so to speak. This here, let's have a look at it. This cylindrical, it's a thickness delta x, it has volume of pi r squared, doesn't it? So that's pi y squared delta x. So if we sum these small volume disks between here, which on the log is 1, and this value here, we should be able to find the volume formed. So part 2, A, here volume, so I'll label it V is equal to, it's the sum between 1 and E, isn't it, of pi y squared dx, like we said, sum those cylinders. So that's the integral between 1 and e of pi, put that at the front there, y squared. Well, y is log x, isn't it? So it's log x all squared dx. So we can integrate this by parts now, can't we? Now we know the integral of log x is x log x minus x from the previous part. So I'm just going to put that up as a reminder. Ln x dx is equal to x ln x minus x, isn't it? If we wrote it down correctly. Yep, that's fine. So we need to turn our attention to this part of the problem then. Here, this is parts, so this is equal to pi, the integral between 1 and e of ln x times itself, ln x dx, v du, and let's see what we get. So it's equal to pi, u v, so u is this, so it's x ln x minus x times v, ln x, and that's between 1 and e, minus the integral of u, which is this thing here, x ln x minus x, more than one term, put a bracket, times the v, which is 1 over x dx, which is between 1 and e, so that's equal to then pi lots of, now we could put this in straight away actually, couldn't we? Because let's put it in. We get e log of e, which is 1, so that's e, minus e times log of e, which is 1. That's the top value. Take away the bottom value, put 1 in, you get log 1, which is 0. So that all works out at 0 there, doesn't it? So that square bracket is just 0. Minus, so we got a minus here, and we need to do this integral now, but we need to times it by, so it's pi. So I can scratch this pi here, because they're all zeros, so we don't need to write it down. So let's move on to the second part then. So it equals pi times this, so I'm going to bring the minus to the front, and it's the integral between 1 and e of, the x can cancel, we just get log x, and then the minus 1 here, dx. So we've got the integral of log x, which we already know, is x ln x minus x, and we've got a minus 1 here, so that's minus another x, and it's minus pi lots of between 1 and e. So what do we get? This is minus 2x, so can I just put that in? So it looks easier on the eye, just to write it straight away. So we've got minus pi bracket. Top value is e times log e, which is e, minus 2e. Top value. Take away the bottom value. Log of 1 is 0. Minus 2, close bracket, close square bracket. So we got minus pi. Minus e plus 2, that's 2 minus e. So run the minus through, it's e minus 2. Lots of pi. So there's the volume. And it is a positive volume, so that's good. E minus 2 lots of pi. So find the volume when r is rotated about OX. R is rotated about OY. Show that the volume is this. Let's have a look at that then. We now want to spin these slices around here. So we're going to generate a cylinder like this, aren't we? Should have been horizontally drawn, of course. So what have we got? We've got a cylinder here, haven't we? Like so. Take away these cylinders in here, if you see what I mean. So I've drawn rather a lot of things, but basically if we just draw this here, we got these heights here, haven't we? These slices is what we're talking about, between naught and this value. So this value when e, log of e is 1, so it's the integral between naught and one of these slices. Delta v, this distance here is x on the curve, so it's pi x squared delta y. Okay, that's what we've got then. That's the volume, pi x squared delta y, and we know what x is. It's e to the y. So let's have a look at this then. Pi x squared delta y. So part B, here, the volume is equal to the integral between 0 and 1, wasn't it, of pi x squared dy, and y is equal to log x, wasn't it? So x is equal to e to the y. So x squared will be this squared, which is e to the 2y, so it's the integral of, between 0 and 1, of pi x squared, which is e to the 2y dx. Now, what do we need to show? The volume is this, pi e squared minus pi. So I've worked out the volume, haven't I? The volume of that cylindrical thing, which I talked about at the outset. So the true volume answer is equal to, now if we go back to our sketch, because we don't want that particular volume, do we? We want this whole cylinder volume up to here, so it's pi e squared. Take away this volume. Pi e squared, pi r squared times 1 is the volume of this whole cylinder. Take away this section here, pi e to the 2y between 0 and 1 dx. And it says here, part B, show that this equals that. I think we need to explain it as well, don't we? Here, the answer is the difference between the cylinder of radius e about OY from y equals 0 to y equals 1 between the cylinder and the volume given by v equals integral 0 to 1 of pi x squared dy, which is what we wrote up here. So that's why our answer is that. So we now need to work at, so answer equals then, let's write it down, the answer equals, let's integrate then, is pi e squared is the first term, minus pi e to the 2y d, e to the 2y, x squared dy. I've decided to write dx here, haven't I? So let's just change that here and here. Pen, it's dy. Just automatically kicks in there. So e to the 2y dy is minus, I'm going to move this stuff up here a minute. So let's just grab it all. Just move it up slightly. Okay. So pi e squared minus this integral, which is minus pi, bracket, e to the 2y is integrates to e to the 2y over 2. And we need to work that out between 0 and 1. So that's pi e squared then, minus pi. And if we put this in, put 1 in, e to the 2y is e squared over 2. That's the top value. Take away the bottom value, put 0 in, e to 0 is a half, so it's minus a half. So we end up with then, we end up with pi. We've got e squared over 2 with a minus and e squared, so that'll be just an e squared over 2. And then we've got plus a half, haven't we? So there's our answer. Pi times e squared over 2 plus a half.